1. Why do you think computers need detailed instructions? 2. Can you think of a real-world example, outside cooking, where giving vague instructions would lead to confusion? 3. Why might Python's simple syntax be helpful for beginners? Show thinking. Here are the answers to your questions. 1. Why do you think computers need detailed instructions? Computers require detailed instructions because, at their core, they are not intelligent in the way humans are. They don't possess common sense, intuition, or the ability to infer meaning from ambiguous language. Here's a breakdown of why. Literal interpretation. Computers interpret instructions in a very literal and precise way. They execute commands exactly as they are written. If an instruction is missing a step or contains ambiguity, the computer cannot guess what the user intended. Lack of contextual understanding. Unlike humans, computers lack a broad understanding of the world or the context of a task. They operate solely based on the explicit information provided to them through code. Fundamental operations. Computer processors understand a limited set of very basic instructions, often called machine code or assembly language. These instructions might involve tasks like adding two numbers, moving data from one memory location to another, or making a simple decision based on a condition. Complex tasks need to be broken down into a sequence of these fundamental operations. Deterministic nature. Computers are designed to be deterministic. Given the same set of inputs and instructions, they will always produce the same output. This reliability is crucial, but it depends on the precision of the instructions. No room for error. In logic, while programs can have bugs, errors in the instructions, the computer itself doesn't make mistakes in executing valid instructions. If the instructions are flawed, the output will be flawed or the program may crash. Managing complexity. Modern software is incredibly complex. Detailed instructions are necessary to manage this complexity and ensure that different parts of a program work together correctly. Essentially, you are communicating with a machine that operates on pure logic and has no inherent understanding of your goals beyond what you explicitly tell it. 2. Can you think of a real-world example, outside cooking, where giving vague instructions would lead to confusion? Yes, there are many real-world examples outside of cooking where vague instructions would lead to significant confusion and negative consequences. Here's one. Scenario: assembling flat-pack furniture. Imagine you've purchased a new bookshelf that requires assembly. The instruction manual is poorly written and contains vague steps. Vague instruction: attach the side pieces to the back panel. Confusion: which side piece goes on the left and which on the right? Is there a specific orientation, top/bottom, front/back, for these pieces? Are screws, dowels, or cam locks supposed to be used? In what order should they be attached if multiple fasteners are involved? Vague instruction: fix the shelves in place. Confusion: how are the shelves fixed? Do they slide in, screw in, or rest on pegs? Is there a specific spacing required between shelves, or is it adjustable? Are there different types of shelves for different positions? Vague instruction: secure the unit. Confusion: secure it to what? Does it need to be attached to a wall for stability? Are there specific brackets or safety straps included for this purpose? What tools are needed? Consequences of vague furniture assembly instructions. Incorrect assembly: the bookshelf might be put together incorrectly, making it unstable, wobbly, or unable to bear weight. Damaged parts: forcing pieces together due to unclear instructions could damage the wood, connectors, or finish. Wasted time and frustration: the assembler would spend a lot of time trying to decipher the instructions, possibly disassembling and reassembling sections multiple times. This leads to significant frustration. Safety hazards: an improperly assembled bookshelf could collapse, causing injury or damage to its contents and surroundings. Incomplete product: the user might give up before fully assembling the furniture due to the confusing instructions. This example highlights how a lack of detail, precision, and clarity in instructions can turn a seemingly straightforward task into a frustrating and potentially hazardous one. Similar issues arise in areas like medication dosage, operating machinery, construction projects, and even in professional communication, leading to misunderstandings in project requirements. 3. Why might Python's simple syntax be helpful for beginners? Python's simple and readable syntax is widely considered one of its biggest advantages, especially for beginners in programming. Here's why it's so helpful. Readability resembles natural language. Python's syntax is designed to be clean and easy to read, often resembling plain English. This lowers the initial cognitive load for beginners, allowing them to focus on understanding programming concepts rather than struggling with complex symbols and strict formatting rules found in other languages. For example, if age greater than 18 is quite intuitive. Reduced boilerplate code. Python often requires less code to accomplish tasks compared to languages like Java or C++. Beginners can write simple programs and see results more quickly, which can be very motivating and help build confidence. Gentle learning curve. The simplicity means beginners can grasp the basics of programming, variables, loops, conditional statements, functions, more easily. They can start writing meaningful code sooner, which reinforces learning. Focus on problem solving. Because the syntax is less of a barrier, beginners can spend more time thinking about the logic and problem-solving aspects of programming, which are the core skills they need to develop. Dynamic typing. Python is dynamically typed, meaning you don't need to declare the data type of a variable explicitly. While this has trade-offs for larger projects, for beginners, it simplifies the initial learning process as they don't have to worry about an extra layer of syntax and rules. Clear structure with indentation. Python uses indentation to define blocks of code, e.g., what's inside a loop or an if statement. While this can trip up beginners initially if they are not careful, it enforces a clean and visually organized code structure, which ultimately aids readability and understanding. Large and supportive community. While not syntax-related, Python's popularity means there's a vast amount of beginner-friendly tutorials, documentation, and online communities. This makes it easier for new learners to find help and resources when they encounter problems. Versatility encourages exploration. Python's simplicity doesn't limit its power. Beginners can start with simple scripts and gradually move to more complex applications in diverse fields like web development, data analysis, machine learning, and automation, all within the same relatively easy-to-learn language. In essence, Python's straightforward syntax reduces the intimidation factor of learning to code, allowing beginners to build a solid foundation in programming principles more effectively and enjoyably.